Okay, number 16. So we have our acceleration function given by this irrational function, 1 over, right, the square root of t plus 4. And we have our initial velocity, right, -1, and our initial position. And remember these guys, right, whoops, it's my white. So this guy means v of 0, right, is -1, and x of 0 is -1. So we start with finding the velocity function, which is going to be the integral, right, of our a of t. So 1 over the square root of t plus 4, right, dt. So we can rewrite this, our function, f of our acceleration function, right? We can rewrite this guy because we're going to take the antiderivative by using the power rule, so we would like a nice power. So we can rewrite this as, well, let's just do it step by step. So we have 1 over, and I know that the square root of t plus 4, that's the same thing as t plus 4 to the 1/2, right? Remember, the square root of x is x to the 1/2. So I just have t plus 4 for x. And I can simplify this a little more, and I forgot my dt. The integral of t plus 4 all to the 1/2, right? Another law of exponent rule, so x to the n is 1 over x to the n. So these are just some algebraic properties that I used. So we are ready to integrate. And so here, this one looks familiar to, I think, one in section 1.1 where, well, we found it was a sine inverse, that was the antiderivative, but here it's not because there's no, t squared. This is 2 squared, but that's not t squared. So just wanted to say that. Here we can use, we can integrate by substitution, so I'm going to let u be the inside function, so t plus 4. So therefore du is dt, and the derivative of 4 is 0, so we don't need that. So we can use these relationships, right, to write the integral of u to the -1/2, right? So maybe there's my t plus 4 and my dt, right? I want everything in terms of u, so there's my dt, but that happens to be du, so I'm allowed to write du. And so taking the antiderivative, this guy is u to the -1/2 plus 1 all over -1/2 plus 1 plus a constant of integration. And our u was t plus 4, so we can replace that with t plus 4, and 1 minus 1/2 is just 1/2 over 1/2. And we can just, again, using algebra, simplify this a little, right? When you divide by a fraction, you're really just multiplying by the negative reciprocal. So that's just 2 times t plus 4 to the 1/2 plus c. Or if you want to change it back to 2 times the square root of t plus 4 plus c, that's fine. So this is our v of t, but we need to find our c. So again, we go back to our initial condition, and at 0, right, v of 0 is -1, so this is what I'm going to use. So if I go back down, so v of 0 is 2 times, well, that's 0 plus 4. Well, v of 0 was -1, I think. I already forgot. I think it was -1. Yeah, -1. Or yeah. So whoops. Let me change this. -1 equals 2 times the square root of 4 plus c. Well, that's just 2 times 2, right? The square root of 4 is 2 plus c. right? And if we solve for c, right, subtract 4 from both sides, and we get -5. So there is our constant of integration, so we can rewrite this function. And we have b of t equals 2 times t plus 4 to the 1/2 minus 5. Okay, so this is our velocity function, but again, we want to find the position function. So now let's integrate this guy, well, actually this whole guy. So let's make it a little bit too big. Okay, so the integral of, and I'll just write all this in 2t plus 4 raised to the 1/2 minus 5 dt, right? This is an indefinite integral, again, because it's a function. When we integrate it, whoops. When we integrate this, right, we're going to get a function. We're not going to get some numerical value like 5. It'll be 5t, or, well, it's not going to be 5t, but just the difference between those two. So we can split these guys. So 2t plus 4 to the 1/2 minus the integral of 5 dt. And so we're almost done. Hang in there. It's a long problem, but again, hopefully you're looking at this and it's just a review of integrating and some algebraic properties. So let's see. Oh, I should probably write x of t equals, since that's what we're doing. Here we can use substitution again, right? I'm going to let u be t plus 4. That's a t, and that's a plus sign. And so du is, again, dt, right? The only difference from above is, right, this guy is positive. The last, our other integral, this was negative. So using substitution, we get 2 times the integral of u to the 1/2 du, right, or if you want to write u in blue, minus, and this one's pretty easy, 5t is this integral plus some constant of integration that we're going to find. And we can integrate this, right? Here this is u to the 1/2 plus 1, right? 1/2 plus 1 minus 5t plus c. And let's see, we can bring, well, this guy, right, 1/1.5 is really 3/2. So we have u to the 3/2 over 3/2. And finally, right, we can bring this guy up. So that's 2/3 times 2. And I can replace my u now, which was t plus 4 to the 3/2 minus 5t plus c. So this is our position function, but again, we need our constant of integration. We have to find this. So to find this constant of integration, we use our prescribed initial conditions. And so our initial conditions, let's see, were they both -1? No, actually. So this one is correct. X naught should be +1. So again, I just highlighted in green so you can see it. So that should be just 1. So X naught is equal to 1. Okay, so, wow, doesn't that look cool? I love that. Okay, so keep going up. So we have x of 0, right? This is going to be, that's 4/3, right? Just multiplying fractions. Our t is 0 minus 5 times 0 plus c. But remember, x naught is 1. So this guy is 4 to the 3/2. 5 times 0, 0, so this is nice. And And just some simplification here. So we have 4, so this really means 4. Have a root. It's the root is 2, and then I'm cubing. So this guy, when you have 3 halves, right, this is the power, and this is the index, right? So this is my power, and this is my index. So another algebraic property, the nth root of x to the m is x to the m over n. So that's what I'm using from algebra. And almost done. 1 equals 4/3. The square root of 4 is 2. 2 cubed, and I'm forgetting my c here. 4/3 times 8. And we have 32 over 3, right? I'm just multiplying numerator and denominator. And finally, just to solve for c, this is going to be, so c equals, so 1 minus 32 over 3, or 3 over 3 minus 32 over 3, right? Because that's the same thing as 1. And let's see, so the denominators are the same. So 3 minus 32 is negative 29. So our C is negative 29 over 3. Okay, so now let's substitute this a constant of integration. So let's go back to our x of t, which looks like it's right, let's see, right there. So x of t, right, we could say 4/3 times t plus 4 to the 3 halves minus 5t plus our constant of integration, which is just negative 29 over 3. So I want to point out that, right, this c, our constant of integration, was not 1. It was this rational number. So that's your position function. Whoops. Wow, that was a good problem. This is a good test question. I had fun. I hope you guys had fun too. Isn't that cool? I love that. The beauty of mathematics. Let's see, hopefully there's no mistakes in there. Okay, that's number 16.